Hello friends, welcome back. In this lecture, we will see multiplication of two complex numbers. Already we have studied what is meant by complex number and how we say that these numbers are complex number. So let a plus ib will be the first complex number z1 and c plus id will be the second complex number denoted by z2. Now we need to calculate z1 multiplied by z2. So a plus ib multiplied by c plus id. So now first we multiplied first term of first bracket to first term of second bracket. AC plus this plus sign into first term of first bracket to second term of second bracket. A plus a into id, iota a into d. Now this plus. Now we multiply second term of first bracket to the first term of second bracket. IB into C, that is iota BC. Now this plus sign. Second term of first bracket to second term of second bracket. I into I square into BD. As we know, I square is equal to minus 1. I square is equal to minus 1. So Z1 into Z2 is equal to AC. I square is minus 1. So minus into plus become minus. So BD will make one group of first real part AC minus BD plus iota. Here in these two terms, iota is common. So we'll take I common. AD plus BC remains in the bracket. So Z1 into Z2, that is multiplication of two complex number, will get complex number. So complex number involves real part as well as imaginary part. So this way you should do multiplication of complex numbers. Now modulus. As we know, what is meant by modulus? It is the positive real value of any function is known as its modulus. So positive real value of any function is modulus of that function. Now we need to find modulus of complex number. As we know, z is equal to a plus ib. This is the complex number. Then modulus of z is denoted by like this. Modulus of z is denoted by like this. Modulus of z is written by like this and is equal to square root of a square plus b square. Square root of a square plus b square. That is the real part square plus real part from the imaginary part. That is the b is the any number or anything. That b. That is the coefficient of iota. You can say coefficient of iota, that square, and square root of this. So you will get modulus. Now third concept is conjugate of complex number. So conjugate is required to find the next quantity. What we can say, that is the multiplicative inverse. Multiplicative inverse. So that we'll see later on. So conjugate of complex number. How to find the conjugate of complex number? Just change the sign of imaginary part. Just change the sign of imaginary part of complex number. So a plus ib is a complex number whose conjugate is denoted by z raised to bar, z bar, a minus b. This sign you need to change. Change the sign of imaginary part, you will get conjugate of this number, complex number. Now next, power of I. Suppose I raised to minus 35. We need to calculate value of I raised to minus 35. I raised to minus 35. Something raised to minus 35 means 1 divided by something raised to 1 divided by I raised to 35. We can write this as this. Like 1 divided by I raised to 35. I will write I raised to 2I square raised to 17 into I. So exponent, I have used index and exponent and power rules. A raised to m raised to n into a raised to L. So a raised to m into n. Solution for this, and solution for this is a raised this 2 for this one formula we need to use is equal to a raised to m multiplied by n, and second formula a raised to m into a raised to n equal to a raised to m plus n. So a raised to first formula 17 multiplied by 2 34, 34 plus 1 I raised to nothing is here is I raised to 1. I raised to 1. So 34 plus 1 32. Then minus 1. As we know, I square is minus 1. So minus 1 raised to 17 into I. So minus 1 raised to 17 is minus 1 into I minus I. Next 1 upon minus I multiplied by I by I. If I multiply this by I, so no difference. So I as it is minus as it is I into I square. But as we know, I square is minus 1. So minus 1 into minus 1. Correct? Minus 1 into I square. Into I square. So minus 1 into I minus 1. So I by 1. So my I raised to minus 35 is equal to I. That is the power of I. Now multiplicative inverse. Multiplicative inverse. So first, what is meant by multiplicative inverse? So first, multiplicative inverse is such that if we multiply any complex number with multiplicative inverse of that complex number, the answer we'll get is a real number. Answer we'll get is a real number. Now see how to calculate multiplicative inverse. So multiplicative inverse is shown or denoted like this: z raised to minus 1, and its formula is z bar divided by modulus of z square. So this is the formula for calculating multiplicative inverse. Now suppose z bar is equal to 2 plus 3i. Example. Then modulus of z is equal to square root of a square plus b square. 2 square plus 3 square. 2 square plus 2 plus 3i. 2 square plus is positive 3. 3 square, which is 4 plus 9 root 13. Modulus of z square is equal to square root of 13 square is 13. Now z inverse is equal to, we know the formula, z bar divided by modulus of z square. Z bar is so here quantity is our first assumption. Z is equal to 2 minus 3i. Our Z is 2 minus 3i. So minus is minus 3. So that's why I am taking minus 3. So Z bar is 2 plus 3i. So we have calculated Z bar here is equal to 2 plus 3i. Modulus of z square is equal to 13. We have already calculated. Modulus of z square is equal to 13. So 2 plus 3i divided by 13 will separate the denominator. Will make this complex number as real part and imaginary part. So 2 divided by 13 plus 3 divided by 13 iota. That is the real part. This is imaginary part. So that is z inverse. It is called z inverse. So thank you for watching the video. If you like it, please do share it and subscribe channel for more such fruitful videos. In the next video, we will learn the properties of multiplication of complex numbers. When we do the multiplication of complex number, they possess some properties. That is closure law, commutative law, associative law, existence of multiplicative identity, existence of multiplicative inverse. That we'll see in the next video. Thank you.